I'm really glad to be here. Really excited to have Alex and Mike here from Laude Institute and Stanford. Guys, you want to do just a quick intros for yourselves and let us know a little bit about where you come from for this call?
I'll introduce myself first. Yeah, my name is Alex. I work at Laude Institute. I've been at Laude for about a year. I was at Google for a while before that, working on like ad recommendations and conversion modeling stuff, and then joined Laude Institute right around when it was being founded. And I'm happy to talk more about what exactly Laude Institute is if you guys are interested later. But yeah, we work on a couple different directions, but we do what we call impact research, which we define as research that doesn't stop at the paper. So we love publishing papers, but we also love producing actual artifacts and products and projects that real users can use in order to adopt the inventions that made it into the research paper. Yeah.
And I'm Mike Merrill. I'm a postdoc at Stanford. Excited about all things agents and evals and autonomy. And yeah, really excited to chat with you guys today.
Right on. Thanks so much. Fred, do you want to do a quick intro for yourself as well?
Awesome. Yeah. Hey, folks, I'm Fred Sala. I'm a professor at the University of Wisconsin-Madison, and I'm also the chief scientist at Snorkel AI. I'm also super interested in all data-centric and agent-focused things.
Super cool. Thank you. Thank you. Kobie Crawford here. I'm developer advocate at Snorkel. Let me throw this first question out. How did you come up with the initial idea for Terminal Bench? And what aspects of the existing benchmarks did you feel were missing?
So I think there was one insight that started Terminal Bench, which is that if you go back a year or so, the primary way that people were interested in getting language models to control computers was through operating computers' GUIs. You had these systems which took visual reasoning models, and they would move a cursor around, and it would click on drop-downs, and it would do things like configure EC2 instances or go book you a flight or something like this. And this made for very flashy demos. But if you ever actually tried using one of these systems, you found that they fell apart pretty quickly. Like they weren't able to maintain a long chain of thought. They weren't very good at precisely clicking on GUI elements. And I think about a year ago, we were thinking like, what's a better way of doing this? And one of the insights that led us towards building Terminal Bench was that, like, even if reasoning visually is not so good, language models are really good at writing code. And they've been good at writing code for a number of years. And so why don't we write code to control a computer instead of relying on this dragging and dropping and clicking through GUIs that might not even be well designed in the first place? And I think that's where like the core heart of Terminal Bench came from, was the terminal is this interface that allows us to control computers through text, which is the modality that still works best for language models. And I think Ludwig and I have been talking about promoting this as a way of doing agentic use. A benchmark seemed like a really good place to get started. And through some previous connections that Ludwig and I had, we were able to meet Andy, who is one of the founders of Laude Institute, who introduced us to Alex, who like really helped get the benchmark off the ground, and great collaborator ever since. I don't know if you'd add anything to that.
Yeah, I guess I would just add from the Laude Institute's perspective, or from our perspective. When I first joined Laude, we spent 3 months building this thing called the K Prize, I guess technically the Konwinski Prize, which is this $1 million prize around SWE-bench, where we built like a continually updating version of SWE-bench that was contamination free, that people could compete on for a $1 million prize. And SWE-bench specifically is you take hub issues that have been closed by some PR that added unit tests, and you give the language model an issue, and then you ask it to solve the problem, and then you run it against the unit tests that were contributed as part of the original pull request that solved it. And we just spent a lot of time looking at that benchmark and thinking about how they implemented it, and it became clear that there was maybe a broader abstraction that didn't constrain tasks to be specific with open source Python repos and pull requests that had to close it. But what if you actually just have a generic instruction container and some sort of test executable like a test script? Then in theory, you should be able to frame almost any task on a computer, which a container is essentially just like a simulated computer. You should be able to frame any task on a computer in this task format. And then that became the task format for Terminal Bench, and the terminal became the tool by which these agents solve these tasks. And Yeah, that was right before the release of all these CLI agents, and then they started to come out. I think Devin had already come out at that point, or their demo had come out at that point, but then Claude Code, Codex CLI, and all of these other ones have come out since then. So I think it is a paradigm that is powerful already in terms of like adoption.
No doubt. Agreed 100% about that. I got to see Mike give a presentation, and he talked about that coder that everybody knows who does everything on the command line anyway. The fact that the OS happens to provide this really rich GUI is, so what? I'm very productive like this, and sit in Vim and do everything from there and crush it. And it does feel like that it remains the case, that the text modality does offer certain kinds of speed and certain kinds of efficiency and like you said earlier about how language models being built on text, then you use the modality that they're built for.
And even the original computers were just terminals. Like the GUI actually came later. So it's proof that is a method of operating computers generally.
It just so happens.
And thanks for that description of kind of the origination of the terminal bench idea. Once you folks came up with that idea, we're curious how you chose to design the benchmark and like what inspired those choices.
I guess I partially answered that in terms of looking at how SweetBench framed their problems informed how we designed what we thought was a slightly more abstract task formulation. There were a lot of questions in the early days of what actually is a headless terminal. Like, how do you give an agent a terminal? What are the affordances of a terminal? You could give it the ability to execute bash commands, but actually a terminal is more powerful than that because from bash, you can activate other programs like Vim and things like that are interactive. So we spent a lot of time, really trying to dial in what does it mean to give an agent a terminal? What are all of the affordances of a terminal, and how do we design that to make it possible for an agent to use? And then specifically, one thing we cared a lot about was making it interactive. So the agent actually had a live container that was running that it would interact with by executing these commands. It could look at the feedback that it was getting from the terminal output and inform its decisions for what to do next. And I think these types of live, like agent interactions with containers to generate rollouts and rewards is also something that has become fairly population centered for both training models and also evaluating them.
I'll add one other thing to that, which I think was a great design decision that Alex really made earlier in building the benchmark, which is to make it as possible to evaluate any agent and any language model inside of our harness. So the way that our harness works is that the agent gets installed directly into the container. And what this means is you don't have to worry about the complexities of hooking up this external environment to your agent. Your agent doesn't need to communicate with your environment over an SSH connection or over an MCP or over some other bit of plumbing. Like, all we do is just take the agent and put it directly into the environment. So this means you can run Claude Code or Aider or Codex CLI or Gemini CLI or Cursor or OpenHands or any of these other agents within our harness because they just get installed directly into there. And really any agent that can be run on a computer can be run in our harness. And we saw that as being huge for driving adoption because anyone could just bring the code that they already had and plug it directly into the harness pretty quickly and get a number back out.
Yeah, that's huge. Super cool. I appreciate the idea that you set up saying this is most generally applicable and any agent can run in there. But by installing an agent inside the container versus exposing like a uniform interface for those containers to connect to, are there any constraints that you feel like you ended up taking on that you're thinking about now?
Yeah. Like I think probably the best example of this is how we handle the termination of a task. So every task in Terminal Bench is given a time limit. And this time limit varies from one task to another. If it's an easy task, it might only have a couple of minutes. If it's a substantially harder frontier task, then it might have several hours. And one limitation of doing this is that if your API calls are particularly slow, or your agent runs particularly slow, or your hardware is slow, then you're more likely to time out because the agent just can't operate as quickly in the environment. This is unfortunate. But the reality is that we do need some way of telling the container that it's done, that the agent is probably stuck in some loop, that it's not going to actually solve the problem, and we need to terminate and move on. You asked about the compromises that we had to make and the affordances that we designed into the benchmark. And the reason that this is a good example is that there are probably more elegant ways of doing this that just wouldn't be compatible with an arbitrary agent. So like one thing you might want to do is limit the number of turns that an agent takes, right? If you said every agent only gets to make 100 turns, then it wouldn't matter what hardware it was running on. It would still time out at a consistent and uniform place. The problem is that there's not a good way of taking an arbitrary agent and getting a hook into it to tell you how many turns it's taken. And it's not even like well defined what a turn is. So if Claude Code calls some sub agent, are we going to count that as a turn? Or are we just going to say that's like part of the main agent loop? Similarly, you could do something like limit the number of tokens that an agent was allowed to use to answer the task. But this would also require you to build hooks into each agent to get that information out while it's executing. And so we just said, we don't want people who use our benchmark to have to deal with this. And so we're going to make the compromise of just attaching a timeout to every single task. And this way, you don't need to write any code to tell us how many tokens you've used. You don't need to write any code to tell us how many turns you've made. Like, we're just going to cut you off after a set amount of time, and everyone's going to be on that same playing field.
That makes sense.
Can I add one more compromise to the list, actually, because I think it illustrates an interesting part of our process. Early in the development of Terminal Bench, we had ideas around how agent developers were going to use the benchmark, and we had ideas around how many tasks people needed for the benchmark to be useful for them. And we took these assumptions and we told Andy, my boss, the founder of Laude Institute, which, by the way, Andy, I should just explain his background really quickly. Andy Kowinski co-founded Databricks and then co-founded Perplexity, took his knowledge from how to turn research into startups and products and open source projects like Spark, and has embodied that into Laude Institute. So that's where this mission around impact research came from. And Andy is very much like a move fast, get early feedback type of person. And we told him these assumptions, and he was like, I think you could release a benchmark with 20 tasks. I don't think people care how many tasks you do. And we were like, no, that's crazy. Like, we need lots of tasks. And he was like, the bigger question is just how are they going to use it? Will they be able to adopt it? So we went and talked to a bunch of different agent developers like OpenHands, even Manus, who has this general purpose agent that uses a terminal. And the consistent feedback we got from all of them is, we don't want more tasks. We want to know how in the world we're supposed to evaluate our agent with its current tools. And at that time, we had not allowed people to install agents into the container to evaluate them. And we ended up having to make that compromise where being able to install and run agents inside a container constrains to a certain degree the types of tasks that you can have, because that means like you need to expect a certain style of environment. For us, it's Linux, like Ubuntu style environment. And then you can't break things like internet connectivity inside the container because the agent has to be able to make LLM calls. So those are some compromises that we made based on feedback that we got from prospective users, because Andy told us to go out and talk to users pretty much. And I think that was critical in like adoption.
Nice. And great to recognize these design decisions actually have that practical impact always, right? So like in every situation, like who your target user is has to be like front and center in the decision process. So that's awesome.
I can ask the next one. And this is like near and dear to my heart, managing big academic projects as well. So I think, yeah, pretty much all the really successful benchmarks nowadays are these very broad collaborations where there's lots of folks who form a community and really help drive things forward. I'm curious how you folks manage that aspect, how you built up that community for Terminal Bench, and how you keep that going.
When people ask me about Terminal Bench, I always say this has been the hardest and most rewarding part of the project, has been like building this community and sustaining it. And it's like the thing that I would be least excited to do again. Not because it wasn't rewarding, but because it's very hard and not something that I had done before either. So I think like initial traction to the community came because Ludwig, my postdoc supervisor, gets probably 1 or 2 emails a day from undergrads or master's students who want to work with him. I think a lot of professors are familiar with this. Fred, I'm sure you've got
familiar
similar inbound. And what I just started doing was every time one of these people would email Ludwig, I would get on a call with them. And so for a period of time there, I was taking like 2 or 3 half-hour calls a day with people who had reached out to Ludwig asking to help with just any research project. And I think something that made those calls successful was we had a very clear ask for what we wanted people to do. If you wanted to help out with the project, you could go and make some tasks. You know, we said if you make 3 tasks, we'll make you co-author on the paper. And if you make fewer than that, we'll thank you and we'll be very grateful. And it's like an easy way to get involved. So having a very clear, highly parallelizable, easy way for people to get involved with the project, I think was huge for our initial growth. There is also this phenomenon of growing an open source project, which actually Andy talked with me a lot about, which is this idea of your funnel, like your engagement funnel. And with any open source project, you're going to get a lot of people coming in the top. People are going to find you on Twitter. People might see you trending on GitHub, and they're going to come check in. Maybe they'll join your Discord. Maybe they'll ask a question. And very few of these people actually convert into serious contributors to the project. Probably like less than 5% of the people are going to actually go on and do something. We have 1,000 stars on GitHub, and we have 100 contributors, and we have probably 5 active contributors, right? And so you need to be able to identify these people, but also have a big enough funnel that when you get down to that 0.5% of people who are going to be active, you still have a critical mass that's going to be able to help out the project. So we made the funnel bigger by tweeting about it, going and talking to everyone we knew, using these people who reached out to Ludwig, promoting in other Discords, like sending out messages on mailing lists. One of our contributors posted on RedNote, like the Chinese TikTok, saying that if people came and helped and contributed to the project in a certain way, we'd make them co-authors. And this led to 200 stars on GitHub basically overnight because people were excited and joined, and his video went viral. There have been many inflection points where the community's grown very rapidly. But I think the fundamental thing that we did well was, like, in the beginning, when we had a small funnel, really hold people's hands through the process and give them clear ways to improve and act on the project. And then at larger scales, the problem becomes about identifying talent and giving people responsibilities so that they feel like they have ownership in the project to make them more engaged members of the community. And that's been our philosophy.
Love it. It also resonates with me both on managing academic projects, which have a very similar kind of funnel experience, often at smaller scale, because we're not always building a big community around a project. But it's also true with the contributors for Snorkel, for example.
Sure.
Lots of folks say they'll help build data, and then you do end up funneling down to the free MVPs who are actually doing 80% of the work or what have you.
Yeah, and those people are so valuable. Every open source project has a core of people without whom the project would be impossible. And there's huge stacks of the internet that are held up on the backs of these like very valuable open source contributors, and we love them.
We treat those people like our customers as well, right? Like we try to think about what are the points of friction that makes it harder for them to contribute to the project. How can we get them onboarded most easily and have the fewest human blockers in their way for getting things merged and taken care of? Yeah.
That makes a lot of sense. Super cool. I love that vibe of treating them like customers, because it's actually different than treating them like colleagues. It's a different approach, thinking about it like the customer point of view. I really like that a lot. And I guess that ties in with the way you described it in terms of the funnel as well, contributions coming in with some way, because on the marketing side, people always talk that way, right? So like it's very interesting as that parallel. That's really cool. Alex, earlier you talked about Laude Institute's approach to research and like what Andy brought to the table on that. I would love to know from your point of view what feels like the sort of like the biggest win for Terminal Bench based on working that way, and the energy around having shipped like a research idea and then actually saying it's got to get out in the community's hands sooner. Are there things that you think about that are biggest there? Maybe you've already spoken about them because it sort of like ties into what's already happened for the project, or are there other things that might come up about that particular angle approach that you might want to bring up?
Yeah, I think I've alluded a couple times to ways in which that mentality or style of research has helped us. I guess in general, just to give the full motivation of how Laude Institute came to be, was Andy was a PhD student at Berkeley. Him and his lab mates built Spark, which was a massive open source success. And they ended up then co-founding Databricks to be like the best place to run Spark. And obviously took that to, it's got to be hundreds of millions of users, if not a billion users at this point. And that's now a $100 billion company. And then Andy, 5 or 6 years later, stepped down from Databricks and went and teamed up with Aravind to create Perplexity. And that was a lot faster. I think they built 7 products in 4 months. So every 2 weeks, pretty much a new product, new demo, until they got to product market fit to what Perplexity is today. And now that's, I think, a $20 billion company. And I think, and Aravind had just graduated from his Berkeley PhD as well. So it came from this like researchy background, trying to then take what he had been researching, which at the time was large language models, and turn it into a product that actually solved users' problems. And I think both of these just highlight the fact that we believe there's this inefficiency in researchers solving novel problems that real people experience, but then not delivering the actual solution to the user. And I think whenever there's an inefficiency, there's an opportunity to create value. And we believe that we will create value by not only participating in impact research ourselves, that's what I do at Laude Institute, but also like funding researchers through quick and fast grants, like $20,000 grants that go to PhD students who want to ship a project that they're working on, all the way up to funding entire labs for multiple years. And I think for Terminal Bench specifically, I guess for me, when I was doing my master's degree, I spent a lot of time trying to make language models take surveys to see if they could accurately predict human opinions or responses to certain styles of questions. And I remember we built this cool framework for how you could like quickly import surveys and have language models take them. But then in my mind, I was like, we need to publish a paper. Like, we're not going to release this framework because that's not our purpose. Like, we're not going to actually spend time writing quality code. And now I look back on that, and specifically with Terminal Bench, it was the exact opposite. We said, we will write a paper, but we first and foremost want to build something that people are going to use and get value from. And I look back at my experience as a master's student, and I think to myself, oh, that would have been such a great opportunity to build and open source this tool so that other people can make language models take surveys as well. It's a simple example, but I do think that thinking about users and use cases has generated a ton of adoption for Terminal Bench, as well as the novel research insights.
Right on, right on. Yeah, Qualtrics and SurveyMonkey are busy saying, phew, we just ducked a bullet because Alex Shaw
Yeah,
didn't
exactly.
release his project. Very no, but that's actually a really great story. I like the point that you make about like actually beginning with practical application as the primary thing. And yes, we will publish, but seeing the first step is actually making it useful and putting it in people's hands. That's awesome.
Can you folks tell us about your new project, Harbor?
We're still working out the right way to pitch this because it's completely new, but I think this is also one of the fruits of the Laude Institute approach to research, which is we built Terminal Bench in such a way that it could be easily used. And because of that, it actually got used in ways that we didn't even anticipate. So we released it as just originally we set out to build a data set, like a benchmark. And we saw people plugging Terminal Bench into their CI/CDs as like unit tests for their agents before they deployed it with tasks that they created themselves in-house. There was this popular project that came out called Terminal Bench RL, which was somebody who used synthetic Terminal Bench tasks to do reinforcement learning on a Quen model. We saw JEPA integrate it as one of their adapters for prompt optimization. So really, there was a broad range of use cases that I guess we didn't necessarily anticipate. And they, at face value, seem like they're maybe completely different use cases. You wouldn't maybe anticipate that there's a common layer of abstraction between all of them, but there is. And the abstraction is containerized environments that you perform rollouts with, and then you return tokens and a reward. And it turns out that's the exact same thing you need for an eval as you need for RL, as you need for prompt optimization. And the container-based interactive approach means it works with agent scaffolds. And agents is the primary form in which language models are now being deployed as like solutions, or at least it's the approach that people are the most excited about, I think. That also requires the most tuning and optimization and confidence in terms of understanding your agent's performance through evaluations. So we have built a new package and repo called Harbor that is essentially everything you need to create and use these environments for all of these different use cases. And our goal was make it as few lines of code as humanly possible to get up and running and scale to hundreds or thousands of containers quickly.
Nice. That's fantastic. One, the idea that you can simplify what people have to do for that, again, you optimize for that use case, sounds like what people typically want. And then my question that follows on to that is, how do you feel about the abstraction that you're choosing right now to offer them? And what do you see as like the pluses and minuses of the choices that you're making around the abstraction that you're providing for that?
I think there's two types of agents that are gaining popularity right now. There's tool use agents, which constrain the action space to be a set of very specific tools that are intended for a very specific task. And then there are general purpose agents, which right now mostly are CLI agents, which have a huge action space, usually an action space as large as the terminal plus maybe like a search or a browser tool. And they're intended to accomplish all sorts of different tasks. I saw like the Anthropic the head of developer relations tweeted and said, what non-coding tasks are you using Claude Code for? And there's this huge string of comments of all these things that people use it for. And then I've seen other agents like Biomni, which is an agent that came out of Stanford recently, which is a computational bio agent, but it also is general purpose, right? It has this massive action space of the terminal. And we believe that these general purpose agents will be popular in many verticals, not just coding, and also that will just be a dominant use case in general. And we're specifically targeting those right now. So rather than going after the tool use agents, maybe we will expand the framework to account for those as well. I think you still need to containerize those to scale rollouts. But yeah, right now we're really focused on providing infrastructure for general purpose agents that use the terminals.
Right on, that makes sense. And then from a configuration and usage standpoint, given what people already are comfortable with using Terminal Bench, what's the delta between how they've worked with Terminal Bench before now to what they would do working with Harbor?
I think what we've done with Harbor is we just made it easier for people to do all the things they were doing already. Let's have a good concrete example of this. So like before, if you wanted to run Terminal Bench in parallel or any of our adapted data sets, we also offer several other benchmarks that can be run inside Terminal Bench, like SweetBench, for example. If you wanted to run one of these benchmarks and you wanted to do it in parallel, you would have to go get the biggest EC2 instance that you can that has 128 cores and like a terabyte of RAM and run 32 Docker containers at the same time on a single machine. And this becomes necessary because there's 500 tasks in SweetBench. Like, what, you're going to run those one at a time locally on your laptop? Doesn't really make sense, particularly if you have the API rate limit for it. But what Harbor offers is this abstraction where we can just deploy into arbitrary containers hosted somewhere on the cloud. So if you're using one of these neo clouds like Daytona or E2B or Modal, you can point the Harbor harness at these containers and then deploy our rollouts there with potentially thousands of containers at the same time. Or you can attach to your Kubernetes cluster and you can run your deployment there. And this is something that you could probably have hacked together using the Terminal Bench harness, but it wasn't abstract enough to make this easy. So that's how we think about it. It's like people are going to keep doing the things that they were already doing with Terminal Bench, but in a way that's like fully supported by the software that we're offering and makes it easier to experiment and evaluate and optimize your agent.
That makes sense. That's awesome. That's fantastic. I saw that in the Harbor repo that like a lot of it is still essentially going to be like a YAML file for providing the config and say, go get these things and then do that stuff. And if people are able to see it as a config step like that, that'll be super cool. When it comes to the containers themselves, are you starting with some assumptions about what will be in the container, or can people start literally from from scratch and go from there? Or like, what are there any like prerequisites that you want like most everybody to provide to make your container viable?
We're not making any assumptions about the container environments. I guess most of the agent implementations assume that Ubuntu will be the operating system running inside the container. But yeah, in Terminal Bench, we have some pre-installed packages, but we actually even pulled those out with Harbor. I think I was talking to one of the leads on SkyRL, which is a reinforcement learning framework out of Berkeley the other day. And he said, actually, often when they have helped people start using SkyRL, the hardest part has been scaling container rollouts rather than the actual weight updates using the SkyRL framework itself. So hopefully, to be honest, we're still working to make this as seamless as possible because to some extent, you're beholden to the reliability of the cloud provider that you choose to use. But I think it's a deceivingly difficult problem to scale these container-based rollouts. Deceiving, I say, because at face value, it appears like it might be simple, but there's a lot of gotchas, I think, that can hit you. So our goal is, yeah, abstract it away for all of the users and let them actually just do their research and their development.
Awesome. Yeah, we should ask you guys the most important question. What's exciting about Terminal Bench 2.0?
Yeah. I think there's a few things that made us really excited to do Terminal Bench 2.0. The first is that we had always planned for this to be a live benchmark. Like from the very beginning, we built versioning into our harness because we anticipated that we'd be making changes to the benchmark as model capabilities changed. It's really important to us that this not become saturated. You're seeing Frontier SweetBench performance being at like 85%, and it's not clear if those final 15% of tasks are well specified or maybe don't have great test cases. And so like we wanted to make sure that there was always going to be room to improve on terminal bench. And what this means is we need to increase the difficulty as frontier models performance increases too. So that's the first thing about terminal bench 2, is that it's harder. The second thing about terminal bench 2 is that it's even better verified than terminal bench 1 was. And so what does this mean? If you look at the tasks in terminal bench 1, you'll find that several of them have bugs that are not the most desirable. Several tasks in terminal bench 1 are unsolvable or very difficult to solve for artificial reasons. Like we may have thresholds that are set a little bit arbitrarily, like an agent could still, for example, train a model that does very well on a validation set, but not a test set. And just for reasons of random noise, it ends up failing. This is not desirable, it's not reproducible. Some tasks aren't particularly robust. So one task in terminal bench 1 requires you to download a video from YouTube, and YouTube is constantly changing its anti-bot protections. And so like a solution that works on one day of the week may not work on another. And this is clearly not desirable for reproducibility. Some tasks are too easy in terminal bench 1. We have this hello world task that we included for debugging, and that was great. Like it's useful for debugging, but it's also not something that we want to be evaluating like the strongest, most badass models out there on, because it's just like an easy point that we give away to every good model. And some tasks also just weren't like intrinsically valuable, or games, like things that might say something interesting about model behavior, but don't tell us anything about the impact of models on the economy and their ability to do valuable work. So we revisited all of these things for terminal bench 2. We made sure that all of our tasks are much harder. We spent hours manually verifying each task. Like Alex and I looked at every task in the benchmark and went through a checklist and ran 1 million agents against it. And
it was excruciating.
It was. I mean, you guys are in the data business, like you get it, right?
Yeah.
Like, it's a lot of just looking at spreadsheets and organizing people and making sure that everything is at the highest possible standard of quality. So we spent way more time on that for terminal bench 2. And I think the end result is a benchmark that is harder, but also substantially higher quality. So like we have much more confidence in every task that's part of the benchmark now. And like I can say with a high degree of certainty that the highest possible score a model or agent could get is pretty close to 100. Every task is possible, and it's like reproducible and consistent. It just has better smells. Like terminal bench 2 just smells better than terminal bench 1 did. And we think when people take a look at the tasks that are in it, they'll agree.
And I will say we have 89 tasks, and you might think to yourself, that is such a random number. Why would you have 89 tasks? And it is literally because we wanted so badly to get to 100 tasks, despite Andy constantly telling us that we don't need 100 tasks, but we really wanted to get to 100. But for us, quality threshold was the most important part of terminal bench 2, because we saw how that could negatively impact a benchmark just because the quality of terminal bench 1 wasn't as good as we aspired for it to be. So we filtered out every single task that didn't live up to that standard, regardless of whether that meant we hit our 100 tasks or not. So there's 89 tasks, but I think it's 89 really good tasks.
It's 89, but you're going to like them.
It's been really fantastic working with Snorkel, and Snorkel contributed tasks, and also some Snorkel team members worked directly with us to help analyze a bunch of data that we generated while we were running all the evaluations. Yeah, Snorkel data has been great, and the Snorkel employees have been great as well. Just a 5-star experience.
Yeah, pleasure working with you guys.
Thank you.
We appreciate you guys saying that.